Hello, everybody. Today we're going to be talking about section 3.4 in your book, linear programming. We actually got to start on this last week through our Elite Pottery Shop, and this is just some more problems, a little different way for me to put these to you so you guys can get some more practice with these. Problem we're going to solve today. I know there's 4 or 5 slides here, but what I did was I broke it up into the different parts so that we can go ahead and solve this problem. It just makes it a little easier for us. 2 manufacturing plants make the same kind of bicycle. The table gives the hours of general labor, machine time, and technical labor required to make 1 bicycle in each plant. For the 2 plants combined, the manufacturer can afford to use up to 4,000 hours in general labor, up to 1,500 hours of machine time, and up to 2,300 hours of technical labor per week. Plant A earns a profit of $60 per bicycle, and Plant B earns a profit of $50 per bicycle. How many bicycles per week should the manufacturer make in each plant to maximize profit? If you get a nice table like we have here, what I have in black is what the book gives you. I've added on another row and another column because this is really nice to work with these problems. We're going to end up setting up a table like we had with our Elite Pottery Shop table that we worked with on Friday. The columns, the things going up and down. When you're setting up the table, you're going to want the 2 things that you're comparing. So Plant A and Plant B, those are what we are comparing. Within Plant A and Plant B, we compare general labor, machining, and technical labor. So those are going to be our columns. But the 2 overarching things that we are comparing are going to be our columns. The things that we're comparing between them are going to be our rows. Most problems do not give you this table, but if you can set them up, they're a big help. So the big one that you'll solve today in your homework does not, so you'll have to set that up on your own. What we're going to add on to this is, just like we had in our table on Friday, we need to have our constraining values. And what we're looking for is going to be our profit. And our profit does not have a constraining value because that's what we're trying to maximize. We don't care how high that goes. We want that to go as high as possible. So in the constraining value with profit, I'm just going to put maximize. Now, if we go up into our table here, I'm going to highlight some important parts. 2 manufacturing plants, they've already got that separated for us, Plant A, Plant B. And we can use 4,000 hours of general labor, 1,500 hours of machine time, and 23 hours of technical labor. Profit of $60 per bicycle. Plant B gets $50 per bicycle. And overall, we're trying to maximize profit. Those are all what I consider to be important information that have not been given to us in the table yet. What these happen to be, the 4,000, the 1,500, and the 2,300 hours, those are going to be our constraining values. Those are the maximum hours that we can use for each of our different types of resources that we have. So our general labor, they tell us that it's 4,000 hours. We can use 1,500 hours of machining time and 2,300 hours of technical labor. The only thing left that we're dealing with is Plant A earns a profit of $60 per bicycle, and Plant B earns a profit of $50 per bicycle. That is straight profit. That is with everything, with all expenses taken care of. That is just pure profit. That is not revenue. for those of you that are in accounting. Moving on, keeping that table in mind with us, we need to write our constraints just like we did in our Elite Pottery Shop. Again, tell me what X and Y are going to stand for. I'm going to let X be plant A. Y is going to be plant B. And I've got two different types of constraints. The first one, common sense. These are not from the problem. You have to just think of these. Common sense would tell us that I'm not going to produce negative bicycles. So I'm going to say that X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. That just says that I'm making 0 bicycles or more in each of the plants. Then I've got my regular inequalities. Where I go for those is I go back to this table here. What's really nice about this is the way that I've set this table up, I can just read across my rows to find my inequalities. What I'm going to leave off is I am going to leave off my profit for the reason that that is going to come into our problem later. So we're not going to worry about that right now. So my first one, dealing with general labor. 10 hours, 1 hour, 4,000 hours. I'm going to turn that into the inequality. 10x plus y. And I've got to keep that 4,000 hours. Now, my question to myself is, am I going to use more than 4,000 hours or less than 4,000 hours? Well, I need to use less than 4,000 hours because that's the maximum that I can use. Going back to my table, look at machining. 1, 3, and 1,500. Those are my key numbers here. I get X plus 3Y has to be less than or equal to those 1,500 hours that I'm allowed to use. And our final inequality is, again, coming back from that table, I'm going to get 5x plus 2y is less than or equal to 2,300 hours. Okay, those are our 3 rows that the book gave us. We just used the constraining values to turn those into inequalities. Now, we need to graph these. This is the best way to find these, find where that feasible region is. First one I'm going to graph, X plus 3Y is equal to 1,500. Remember, just for the sake of graphing our lines, we can use the equal sign, then come back and use our inequality to figure out where we need to shade. Again, the easiest way to do this is going to be finding our X and our Y intercepts. Actually, I'm going to come back on this slide here, and I'll find those there just so we can reference those back a little bit. We know that our X-intercept and our Y-intercept. X-intercept here. I know that Y is 0, so I get that X, 10X is going to equal 4,000, or X is going to be 400. Y-intercept, I know that X is equal to 0, so I get that Y is equal to 4,000. Again, go through this one. I will work this one in green. So if y is 0, I get that x is 1500. And I know that if x is 0, 3y is going to be 1500, so y is going to be 500. And the last one, work that one in red, so everything I do for this line will be in red. I'm going to get that if y is 0, I get 5x is equal to 2300. And if I divide that out, I should get that 5x is equal to 2300, or that x is equal to 460. If x is 0, I get that 2y is equal to 2300, or y is going to be 1150. Now, I kind of know my big x and y intercepts. I know where they should be. All right, we found our x and our y intercepts, and I took a quick commercial break here so that I could end up graphing this. I don't want you guys to watch this video for forever, and we've drilled graphing inequalities quite a bit. We'll get more practice with it as this unit goes on. So what I did was I ended up graphing these lines for you for the simple fact that I don't need to take the time to graph these lines, and I get a better picture this way. I'm going to show you how I got some of my points. I know this one doesn't show a lot of our x and our y intercepts, so I'm going to show you how to get some more points even if you don't have those on there. The reason being is we want to be zoomed in on where these lines are going to cross and give us the best picture possible. Usually what I try and do is have those intercepts in here, but with those big intercepts that we had from our lines, you know, we had them out here at 20, you know, we had it at 500, 4,000. You know, those are a little unrealistic for us to graph. If you're using your own graph paper, you can definitely do that because you have the ability to expand that. But with the graph that we have, we got to work with what we've got. So what I did, so if I start with x plus 3y is equal to 1500, that had an intercept that was not nice for us. That ended up with x at 1500. Our graph goes up to 650. Again, I labeled by 50s, labeling every other one just to make my graph a little neater. Makes it a little easier for us to read later on down the road. What I do is I'm just going to pick an x value and I'll find my y, or I could pick a y value and find my x. I'm going to pick an x value of 600. Why 600? Well, it's going to give me the biggest spread of my graph that I can and make it pretty easy. So I then just plug that in. I get 600 plus 3y is equal to 1500. I subtract my 600 from both sides, and I get that 3y is equal to 900. Divide by 3, and I get that y is equal to 300. That's what I did with a lot of these points here. I plugged in, you know, 300 for my x on my red line because I couldn't fit that y-intercept on there. That was really big at 1150. And I did the same with my black line, plugged in, you know, plugged in some different values just to see what I got. And that's a perfectly reasonable way to get points for your line. Intercepts are the fastest and the easiest, but if you can't fit them, you want to make something a little bigger, a little nicer like this, you can go ahead, plug in x values, find your y's. Again, looking at our inequalities, you can check the point 0, 0. None of our lines go through there. So these three all shade down towards 0, 0. And now we need to look to where these lines cross. I will highlight those points in blue for you. So, remember, we have y is greater than 0 and x is greater than 0. So, even though it looks like they're just points on my graph, I have a vertex here. I have one here. I've got one here, and I've got one here. Some of these turn out to be really nice even points for us to find. Some of them not so much. One of the things that I like to have you do, list out your vertices. Vertices is the plural form of vertex. Vertex is where you're going to have a corner. The one everyone forgets, 0, 0. Don't forget that. I don't like to take points off for that, but if I ask you to list all the vertices, that is one, so I need that there. Another one that we're looking at, 0, 400. Right down there in the bottom right. I'm going to go in a... I'm going to pick out the easy ones here first. Actually, that is 0, 500. If I'm going the other way, going up top here, I'm sorry. Then at the bottom, I've got that x-intercept, so I'm going to have 400, 0. And this one, intersection of the red and the green line. That lands really nicely at the point 300, 400, and the last one, where the red and the black line cross. This doesn't necessarily cross at a very nice even point for us. If you know what you're looking for, it's 380, 200. How I found that was you can actually use your substitution or your elimination method to find where that point is. I would probably use elimination. I tend to lean towards that a little heavier than I do substitution. But whatever method you choose, you should get that the black and the red line intersect there. Those are all your vertices. Now, the next part of doing this is we have to find the objective function. This is what's going to help us find what our maximum profit is going to be in this case. So, to find our profit, going back to our table, I get $60 per bike at plant A, $50 per bike at plant B, and we're looking to maximize that, just like we did with our pottery shop the other day. We're going to get 60x plus 50y, and we don't need to test every region there. You're just going to test your vertices. So if I go 0, 0, 0, 500, 300, 400, 380, 200, and 400, 0. Then you simply just plug these in. So you're going to get 600 or 60 times 0 plus 50 times 0 to get a profit of $0. You're going to get 60 times 0 plus 50 times 500 for a profit of 25,000. Again, moving on to our next point, you're going to take 60 times 300 plus 50 times 400. Give you a total profit of 38,000. $60 times 380 plus 50 times 200 gives you a profit of 3280 or 32,800, sorry. And 400 0, I'm going to get 60 times 400 plus 50 times 0 for a profit of 24,000. Now, from here, it's pretty easy to see that right here at $0, that's my minimum. And at 38,000, that's my max. I'm looking to maximize my profit. So that tells me that from factory A, I want 300, and factory B, I want 400. It's a good habit to get into checking all of these because just because they seem to follow a pattern, they do not always. So always check all of your vertices. This again answers our question, how many each factory should produce. From there, go ahead and that's your answer. So we'll get some more practice with these throughout the week. If you have any questions, shoot me an email or catch me during study hall. Here's your homework. The first two, they give you the objective function, and the last one is one kind of like this where you have to go through the steps on your own. So go ahead, use some graph paper to work on this. That'll help you quite a bit. And if you have questions, let me know. And I will see you guys tomorrow.